Alright, so in this video I'm going to be showing you guys how to make box plots, and you're going to need on your chapter 2 outline the second page in order to make this. So what is a box plot? So we're given this data here, and what we're going to be asked to do is produce a box plot and then describe the distribution. I'm just going to be focused on this video on how to actually create the box plot. You formerly called box plots box and whisker plots. So if you've ever done a box and whisker plot before, which I know you did with Mr. K last year, then you should know exactly what I'm talking about. Okay, so the first thing we need to do is we need to go ahead and scale this box plot. So I'm just going to go ahead and produce a line, kind of a long line. And just like any other graphical display, we're going to make sure we have a title and that we have labels and that we have tick marks. And of course we can put arrows at the end of both of our lines. Okay. We're going to need some important information before we start. So we're going to need to find something called a 5-number summary. And I'm just going to go ahead and put this information over here on the side. So 5-number summary. The 5-number summary are actually numbers that your calculator is going to give you. So you are going to need your calculator for this. And the first thing you're going to do is you're going to input all of this data into list 1 on your calculator. And we know that we go to stat, edit, and list 1 in order to get that list of information. So go ahead and pause the video and do that now. Okay, so now you've probably put all of the data in your calculator. So the next step that you're going to do is you're going to clear out of your screen by going to second mode. And then I'm going to go to, just like what we've been doing, stat, calc, 1-bar stats. Make sure that you don't have anything in the frequency list. You could put 1, but please make sure that it's not list 2, and then click calculator. Okay, so we've already talked about what these statistics mean, but now we're going to scroll down. The 5-number summary begins with min, the minimum number of the entire data set, Q1, which is going to tell us the first data value that's in the 25th percentile, the median, Q3, which is the 75th percentile, and then of course the maximum, which is the highest data value. So if I wanted to find the range really easily, I could actually do 8 minus 1.3, and that would tell me the range for the entire data set. So let's go ahead and use this information. We're going to first record this here, so I'm going to just put min, and I'm just going to list out each of these. So this is 1.3. Okay, after I've written all these down, these are going to actually tell me where on my picture I need to have data points. So all of this information is something you would want to write down for an AP test as well. Okay, so I'm going to pause the video real quick, and I'm actually going to go ahead and scale my axis so that I have enough values between 1.3 and 8. And I'm going to go ahead and title my graph as well. Okay, so I just want to note a few things that I added here. I did a title, I did a label, and I did my tick, tick, ticks. I went ahead and scaled by 1 centimeter each. So now I'm going to go ahead and I'm going to compute one more thing before I start graphing, and that is that I want to find the fences. What are fences, okay? So fences are going to help me know where my outliers are. So in order to compute a fence, I'm going to write the word fence here. Okay, anything beyond the fence boundaries is going to be considered an outlier. So the first thing I need to find is the IQR, which I know is Q3 minus Q1. And of course, we know that in this situation, Q3 is 6.35 and Q1 is 4.45. So that's going to give us a value of 1.9. Now this is an important number, and we're going to be using our interquartile range to help us with indicating whether or not something is an outlier. Okay? So let's go ahead and figure out what our boundaries are. So if I have 1.5 times the IQR, so this is a multiplying thing that we're doing here, this is going to be how far away something can be, up to 1.5 times away from the middle 50% before it's considered an outlier, okay? So in order to find this number, I'm just going to do 1.5 times 1.9, And here, when I compute that, I should get 2.85. So this number is going to be used to help us with our fences. Now we're going to have something called a lower fence and an upper fence. So first I'm going to do my low fence. So my low fence is going to be Q1 minus the fence length. Okay? And that's the formula for it. And the way I'm going to find that is by doing my Q1 value minus, well, we actually already know what 1.5 times IQR is. It's 2.85, which means my low fence is going to be at 1.6. This is my low fence. Now let's go ahead and do the high fence as well. Okay? So the high fence is going to be Q3. This is the upper part of our middle 50% plus 1.5 IQR. In other words, this is going to be 6.35 plus my 2.85, which is going to give me a value of 9.2. Okay, so if you're not sure why we're using these, it's going to make a lot more sense in just a second. Let's go back and graph our 5-number summary. So the first thing I want to do is I want to find the Q1 value, which is 4.45. I'm going to go to 4.45, which is approximately between 4 and 5, and I'm just going to put a line like this. Now I'm going to do a line for the median. So this is Q1. My median is going to be at 5.4. And I'm going to label that median. Q3 is going to be at 6.35. Okay, and that's my Q3 value. Now, my actual box is going to be created right here from connecting those three values together. Now, the minimum value is going to always refer to the number that is the smallest number within the fence. So it may not necessarily be 1.3. And your maximum is going to be, but I'm going to go ahead and put a dot there just so you guys can see. So 1.3 would actually be here. Okay, that's my minimum, but we're not going to connect it yet because it might actually be beyond the borders. Now let's try a maximum. Our maximum is at 8. Okay, now why do we need the fences? The fences are going to tell me what is an outlier. It's going to answer the question of what in my data is an outlier. And the reason this is important is because we're going to be able to use this when we cuss, right? We're going to now be able to actually tell if something is more than just a potential point, okay? So now I'm going to go ahead and I'm going to graph my fences. So my fences here, my low fence was at 1.6. So this is my boundary line. Anything that is lower than 1.6, and I'm just going to do a little dash line for my fence, is going to be considered an outlier. And therefore, this is going to be considered an outlier because it is below the fence. Now I'm going to do my higher fence, which is 9.2. So that's going to come over here. Again, I'm just going to do little dash lines to designate that that's a fence. So that means my maximum is okay. It's within the fence. In fact, there's no data on this side that would be considered an outlier. Your the whiskers of your box and whisker plot are always going to be the highest values that are still within the fence. So in this case, we are going to put kind of a thicker dash line here because this is going to be the whisker, the upper whisker. Now, we can't connect this to the box plot because it's beyond the fence. It's an outlier. So we're going to do the next value that occurs that would be greater than 1.6. So let me look at my points over here. So we can't use this number. So what's the next smallest number besides 1.6? It looks like 3.2 is the next smallest number. So 3.2 is going to be the value that I'm going to plot my other whisker at, and that is the smallest value that is within the fence. Okay? And so this is how you create a box and whiskers plot, y'all. And just a reminder that you need to always make sure that you are providing good labels on everything when you do that. Tomorrow we're going to learn how to do extreme outliers. But for now, this is actually going to be called something called a mild outlier, and we'll learn more about what it means to be an extreme outlier tomorrow. Thanks for watching. Have a great day.